Welcome to this session on analytical techniques for polymer characterization, brought to you by Resolve Mass Laboratories. Polymers are the building blocks of modern materials, from flexible packaging and medical devices to aerospace composites. But have you ever wondered, how do scientists really know if a polymer will perform as expected? That's where polymer analysis comes in, a fascinating world of scientific detective work that reveals a polymer's molecular secrets. In the next few minutes, we'll walk through key techniques used to understand polymers, their structure, and their behavior. Unlike small molecules, polymers are complex. They're long chains made of repeating units, sometimes with branches, crosslinks, or blends. Because of this complexity, characterizing them isn't easy, and even many research projects only scratch the surface. Polymer analysis helps us understand four major aspects: the molecular weight, which influences strength and flexibility; the structure, which determines properties like crystallinity; thermal and mechanical behavior, showing how they respond to heat and force; and finally, their surface and morphology, which affect adhesion, coating, and interaction with other materials. Every product, whether a biodegradable plastic bag or a high-performance aircraft component, depends on knowing these properties precisely. Let's start with molecular weight, one of the most important parameters in polymer science. Think of it as the size of the polymer chains. A high molecular weight often means a stronger, tougher material. The go-to technique here is gel permeation chromatography, or GPC. In simple terms, GPC separates polymer molecules by size as they flow through a column. Larger chains exit first, smaller ones later. From this, we calculate values like Mn, Mw, and the polydispersity index, which tells us how uniform the polymer is. For even higher precision, light scattering techniques, both dynamic and static, come into play. They measure how light bounces off polymer solutions to estimate molecular size and aggregation. And when working with smaller polymers, osmometry is a reliable method to determine number average molecular weight. Each technique offers a piece of the puzzle that helps manufacturers ensure consistent quality and performance. Next, we move from how big a polymer is to how it's built. The structure defines everything from flexibility to chemical resistance. One of the most powerful tools here is nuclear magnetic resonance, NMR spectroscopy. NMR lets us peek into the atomic arrangement, identifying monomer units, branching, and tacticity, which is how polymer chains are spatially arranged. Fourier transform infrared, FTIR spectroscopy, on the other hand, works like a molecular fingerprint. It identifies the specific chemical bonds and functional groups in a sample, great for spotting impurities or tracking degradation. Finally, X-ray diffraction, XRD, reveals whether a polymer is crystalline or amorphous. This helps in understanding phase transitions and blending behavior. Together, these methods form the foundation of structural understanding in polymer science. Every polymer behaves differently under heat. Some melt, some soften, and some degrade. Differential scanning calorimetry, DSC, is the technique that tells us about those transitions, like the glass transition temperature, TG, melting point, TM, and crystallization behavior. Thermogravimetric analysis, TGA, meanwhile, monitors how the polymer's weight changes with temperature, a direct measure of its thermal stability and composition. And for understanding viscoelastic properties, how a material stores and dissipates energy, we use dynamic mechanical analysis, DMA. These techniques are critical for selecting polymers for specific applications, especially where temperature resistance and stability are key. Beyond chemistry and temperature, polymers must also withstand physical forces. Tensile testing tells us how strong and stretchable a material is. Impact testing measures how well it absorbs shock, important for packaging and automotive parts. And hardness tests, like Shaw or Rockwell, measure resistance to surface deformation, a quick but useful quality control tool. Together, these tests provide a full picture of a polymer's mechanical reliability, something no engineer can afford to overlook. Now, let's zoom in, literally, to the surface. The surface of a polymer determines how it interacts with coatings, adhesives, and even biological materials. Scanning electron microscopy, SEM, offers detailed 3D-like images of fracture surfaces and coatings. Atomic force microscopy, AFM, goes a step further, measuring nanoscale features and mapping surface roughness and elasticity. And through contact angle measurement, we can quantify how wettable a surface is, a key factor in coatings and adhesion science. These techniques make polymers not just functional, but customizable for real-world applications. Polymer analysis continues to evolve. Techniques like Raman spectroscopy allow non-destructive chemical mapping, while time-of-flight secondary ion mass spectrometry, TOF-SIMS, gives precise surface composition and depth profiling. Rheology is another growing field, studying how polymers flow and deform under stress. These advanced methods give us a deeper, more dynamic view of polymer behaviour, paving the way for smarter material design. In summary, polymer analysis isn't just about numbers and graphs. It's about understanding materials deeply, predicting how they'll perform in the real world. From GPC and NMR to DSC and SEM, each technique contributes a unique insight into molecular structure, stability, and performance. By mastering these tools, industries can innovate with confidence, building safer, stronger, and more sustainable products. At Resolve Mass Laboratories, we bring science and precision together. Based in Canada and serving clients across North America, our team specialises in polymer characterization and analysis. Using cutting-edge techniques like GPC/SEC, FTIR, DSC, TGA, NMR, and rheology. But beyond data, we deliver understanding, helping our clients interpret results, meet regulatory standards, and make informed R&D decisions. Whether you're developing new materials or ensuring product compliance, partner with Resolve Mass Laboratories, where technical excellence meets trusted results. Thank you for watching, and don't forget to subscribe for more insights into advanced material science.